Hello everyone, Mr. Schultz here. Welcome to Integrated 1. We're going to be discussing Module 3, Section 6, Sketching Graphs and Comparing Functions, where we will sketch graphs and compare functions. So we're going to sketch the graph of this linear function, cycling. In 2015, Gustav Strasser set a new 24-hour cycling record by riding 556 miles in a 24-hour period. The distance he rode over 24 hours can be represented as a function. Sketch a graph that shows the distance traveled, y, as a function of x. So, first off, why don't we label our x and y intercepts? So, x. The x-axis would be time traveled. And we should probably say hours. Because if we're talking about 24 hours, that's probably what we'd probably want to do. Now, this would probably be distance traveled. And this would be in miles. Yeah, miles. And we'd probably want to put it in parentheses. So we can make a couple of assumptions right here. We're going to make the assumption that, hey, he travels at a constant rate of speed, and a few other ones as well. So before he's traveled any distance, or before he's traveled any time, he's at the starting location, which would be at, at 0 hours, he has traveled 0 miles. Therefore, the x-intercept and y-intercept is at 0, 0. There we go. Now, we are assuming right here that he travels at a constant rate of speed. Assuming he travels at a constant rate of speed, therefore, the graph is linear. It's done. If he travels at a constant rate of speed, that's like the definition of a linear equation. It's traveling at a constant rate of speed. It has one speed, and that's what it goes. Now, as he increases his time, he will increase his distance he's traveled. So this is going to be a positive. So as the x value increases, well, that's the next one. But this whole graph is positive since you cannot have negative time or distances. There you go. Now we're getting into the increasing and decreasing. Reading from left to right, as the x value, increases, the y values increase as well. So the line is positive and it's increasing. Let's go on. This last part right here, technically it's like the same thing we just said. From the beginning of the race, the x values increase and the y values increase with them as well. It just keeps increasing. All right, let's go on. All right, example 2. Sketch the graph of a symmetric function. So a person's happiness can be affected by temperature. Sketch a nonlinear graph that shows the happiness of a person as a function of temperature x. Interpret the key features. So it's positive between 25 degrees Fahrenheit and 89 degrees Fahrenheit. It's negative for temperatures less than 25 and greater than 89. For temperatures less than 57 degrees, it's increasing. For decreasing for temperatures greater than 57 degrees. So there's a relative maximum at 57 degrees Fahrenheit. All right, well, let's start drawing it. Actually, what I like to do is I like to look at the end behavior. So for temperatures 25 degrees Fahrenheit, or X is less than 25, the graph is negative. So if it's above 89, then the graph is negative. All right, well, let's draw that. So, in fact, I'm not gonna use this graph. I'm just gonna draw it right here. So we have our drawing right here, at 89 and at 50, no, not 57, 25. We have our end behaviors. It's going like this. All right, so then it says, hey, it has a relative maximum at 57. So this is X equals 57, X equals 89, X equals 25. And then it says, hey, it's going to be negative, less than, and greater. Okay, I got that. It's positive between here and here. Oh, okay, so it's that. So it probably looks like this. Here's our X, here's our Y-axis, here's our X-axis right here. And then it's increasing for temperatures less than 57. Okay, so it goes like this. Oh, and it's decreasing. Wait a second. This looks like a parabola. It looks like that. So basically, when we're reading it, we have to look for the keys. So the key part right here was figuring out this, and then figure out what happens in between. We figured out our end behavior, and then we figured out our end behavior right here, and then we figured out, all right, what happens in between these points right here, and then we drew it. All right, let's go on. So sketch the graph of a nonlinear function. So let's wait. All right, so we're gonna have to kind of be a little bit, try it, because it's going to be kind of on this. So the relative maximum, let's put the relative minimum and maximum right here. So the relative minimum is at 65, 31, which would be right about there. And then the relative maximum is at 10, 39, right about there. So that means this is high and then it goes low. And it's going to go high again. This is going to go low. So it's positive for time greater. Okay, so it's going to be, because you can't have negative months and we can't have negative listening to things. Like you can't go negative, like I listened to this song negative 5 times. That's not possible. So it's going to be all positive. Okay, well, negative. Okay, so like we said, there's no negative real world values right there. Okay, cool. So we don't have to deal with that. It's increasing between 0 and 10 months. Okay, well, and for time greater than 65 months. Well, okay, cool. We know it's going up. We know it's going up to here. Okay, done. Between 10 months and 65 months, it's decreasing. Okay, so we know it's going down. And the intercept is at 0, 37. Oh, well, that doesn't work. All right, well, I have to erase that one. This one right here. The intercept isn't at 0, 0. It's at 0, 37. So it's like right about here, and it's going up. Okay, cool. I satisfied that. Fine. As x decreases, y decreases. Yeah. As x increases, y increases. There we go. So there's our example. You also know that this was one of the homework problems you could have done. All right, let's go on to example 4. Compare properties of functions. Tennis. Hawkeye is a computer system used in tennis to track the path of the ball. It is used as an officiating aid to locate the landing spot of a tennis ball when players challenge a call. Use the description and graph of a player's forehand and backhand shots to compare the paths of the two shots, if y is the vertical height and x is the distance. Alright, so for the first example 1, 2, and 3, we pretty much drew the graph, sketched it. Now we're comparing. What are we comparing? We're comparing two different functions. How are we comparing them? Well, one's going to be the actual graph and the other one's a description. So let's go. This is actually going to be our last example for today, so let's see if we got this. Alright, so let's do the x-intercept. It looks like the x-intercept of the backhand is going to be at 70 feet. 70 feet. Alright, cool. Let's type that in. 70 feet. And the y-intercept, it looks like it's at maybe 2.5. 2.5, or no. Yeah, 2.5 feet up. The extreme. I would say that's right about here, which would be 35 feet. Or at 35, 7 feet. Increasing and decreasing. Okay, well, as, from x. Alright, well, give me a second. Okay, so it increases, so from x equals 0, it increases from a height of 2.5 feet to a height of 7 feet at 35 feet. It then decreases from that point until x equals 70, where it hits the ground. Alright, let's do the forehand. During the forehand, the ball leaves the racket at a height of 2.8 feet. Okay, well then it's going to be 2.8 feet. And travels 29 feet. Okay, so the extrema is going to be 29 feet. So the extrema is going to be 29 feet when it reaches a height of 10 feet. So 29, 10. Then the height of the ball decreases until it hits the ground at 58 feet, where it was hit. Okay, so 58. Alright, well, now we just take this information. This is going to be the same type of shape, same parabolic shape or quadratic. From x equals 0, it starts at 2.8 feet, then increases to a height of 10 feet, where it then will decrease until 29 feet. X equals 29, where it will, meaning the tennis ball, will hit the ground. Okay, that's it. That is our... Now what we do is we can compare them and say, hey, look at the x-intercepts. Hey, look, the x-intercepts, the backhand goes farther. The y-intercept, the forehand starts higher. The extrema, it looks like the backhand is farther away, but it goes lower, whereas the forehand is closer, but it goes higher. And so the increasing and decreasing, it's kind of like the same, but like using this information and describing it. Alright guys, we're going to go on, and I'll see you guys in class. Bye everybody.